Caterpillar Oil Aeration Test evaluates aeration performance. In other words, an oil's ability to evacuate entrained air that is present in an oil as a contaminant. This is especially important in regions of main and connecting rod bearings, as high concentrations of air could lead to oil starvation at these locations, catastrophic failure, or significant wear.
Previous tests for air contamination, the EOT, uses hardware, which is becoming scarce, and a procedure that exposes the engine technicians to hot oil.
Unlike its predecessor, this test utilizes a continual circulation of lubricant to evaluate engine oil aeration contamination in real time and in situ. Apart from driving a truck down the road, this test is the closest thing to real-world conditions.
The coat is conducted in a 13-liter Caterpillar engine. It will require approximately 1 drum or 55 gallons of test candidate because it is a flush and run test, determining air contamination through an oil sensor without having to remove the oil from the engine.
This is different than most standardized engine test types, where those require either a partial or full engine teardown and rebuild. In this test, the only thing that occurs in between each test run is an oil change and flushing.
While the engine runs, a portion of the test oil is diverted to a sensor called the micromotion to determine the oil's density. Oil flows freely to and through the micromotion and back into the engine throughout the entirety of the test, providing 50 hours of oil density data.
And the test currently utilizes standardized test fuel PC10, which is an ultra-low sulfur test-grade diesel fuel.
Also, the test does not use a dynamometer to provide a counterforce against the torque of the engine, because the test is simply to get the oil up to a typical running temperature and then have the crankcase splash through the oil to create air contamination into the oil.
The measurement of air contamination concentration in units of percent is averaged for the final 10 hours of test duration.
Caterpillar decided that the acceptable level of air contamination is 11.8% based upon data when the test was introduced into API CK4 and FA4 in 2016. The coat will be part of ACEA E8 and E11, and that reason is because resistance to air contamination is still a significant part of the design of the next generation of crankcase lubricants. If a lubricant can resist air contamination, it can function properly in the engine brake. The end user benefits by having a safer vehicle that can stop quicker and with consistent and better fuel injection, thereby having a lower cost to fuel the engine.
What this means for the fleet owner and operators is enhanced protection and reliability of the equipment, now as well as in the future.